Okay, this is number 8 on 4.17. I abbreviated some words to write this out because I don't want to take the whole screen out typing. But basically, Bethany Christian School performed a play on both Thursday and Saturday nights, and if you added together how many people came in all, there were 1,088 people. All right, so we're trying to set this up, and we know that there were 2 nights, and they want to know how many attended Saturday night. So we're trying to find the attendees on Saturday night. There were also some people that came on Thursday night, and I know that probably what's going to happen, if you think about it, if we're adding together the people on Saturday plus the people on Thursday, that the total number of people was 1,088. That was our total. So you could write it out in words, or you could do something like that, which seems to be what a lot of you like to do. So I can see what I'm going to also need to know for this equation is the attendees on Thursday night. So I need to describe those two things so I could put them in my equation. Okay, so let's see. Let's start reading. Let's look for keywords. They performed a play. Okay, I see the word as. And do you remember that when you see the word as or than, the thing that comes after it usually makes a good variable. So if you look, what comes after it? Thursday night. Let's make Thursday night our x. I'll just put an x over it. So Thursday night is our x. Now remember, what in the end what I want to know is the number of people attending Saturday. So I'm going to go ahead and write this down here, and this is a good idea to do. They want to know who came on Saturday night, and so that I make sure I answer the right question, what I might do, and a good idea for you to do, is to go ahead and write down your sentence for your answer, and you could even go ahead and circle it off to the side, and that way you're sure you're concentrating on getting the right thing. Okay, so Thursday night is X, but now we got to describe Saturday night, so let's back up a little bit. 3 times as many people attended on Saturday night as Thursday night, so 3 times. So what is Saturday night? It's 3 times as many that night as Thursday night. Well, there were X on Thursday night, so 3 times X is what we want to do. Now, here's what you got to remember now. We got our whole equation. We need to solve it. But first, before we solve it, we're going to simplify it. We have 3X plus, that's a 1X. Remember, the lazy math guy didn't write it, but that's what we're supposed to think. 3X plus 1X actually is 4X. So we got to simplify before we start solving. And once we simplify it, we go, oh, this is not going to be so bad, because to solve for x, all I'm going to have to do is just divide both sides by 4. Okay, so I get x equal, let's see, 4 goes into 10 twice. 8, 10 minus 8 is 28. That would be 7. So 272 is x. Now, what a lot of people did is they just circled x equal 272, and they went on their merry way. You did so much work, but you didn't answer the question that was asked, did you? Because what they wanted to know was who attended on Saturday night. And if you look here, I should have written it up here. Saturday night was 3x. So it's 3 times 272 is how many people came on Saturday night. And remember, because I wrote that down there where I remembered it, I didn't just circle my x and go on to the next problem. So we have to say 3 times 2 is 6, 3 times 7 is 21. Put down your 1, carry your 2. 3 times 2 is 6, and 2 more makes 8. So 816 people is who attended on Saturday night. And so you've got to remember, you got to answer the question the word problem asked. Okay, so number 10, Owen is 3 years less than twice as old as his sister Sarah. And if Owen is 13 years old, how old is Sarah? So the question they're asking me to answer is Sarah is blank years old. So I'm going to go ahead and write that because it's going to be really easy to, possibly get Owen's age as we solve and then answer the question wrong. So we'll just make sure we're staying on track. So there's 2 people here. There's Owen and there's Sarah. And we've got to describe both of them. And this one's a little bit different in that we don't have a total going on. So let's just start reading. Owen is equal to, and we got Owen equal to right here, 3 years less than, okay? So 3 years less than means I'm going to subtract 3 from something. It doesn't mean 3 minus something. It means subtract 3 from something else. All right, so what am I going to subtract it from? Okay, and also notice that as we've done this, we've ran across this word than. Less than was a switching order word. That's why we put -3 instead of 3 minus. So that was the first thing that than does. But than also tells me what my variable, whatever comes after than or as, tends to be a good variable for a problem. So what comes after than? Oh, look, here's an as, and here's another as. What comes after all of them? Sister Sarah. So we're going to call Sister Sarah X. She's X. Okay, so now when I do find X here, that will be the answer to my question. It's not always, but it is here, okay? So if Sarah's X, let's go back. Owen is 3 years less than, so we're subtracting 3 from twice as old as Sarah. So twice Sarah's age. So that would be 2 times Sarah's age, and Sarah's age is X, so this would be 2X minus 3. Okay, that was the first sentence. Now, if Owen is 13, oh, they just told me that Owen was 2X minus 3, but now they're telling me he's also 13, so I could also have put a 13 there. If Owen is 13, how old is Sarah? Well, we need to find X, don't we? Do you notice that right here you got an equation? You described Owen as 2X minus 3. You also described Owen as 13. Since those two things are describing the same thing, that's what it means to be equal. It means they're the same thing. So we could set them equal to each other and solve for X, and we'll find out Sarah's age. Now, we don't have any simplifying to do here, no like terms to combine. And all of our variables are one side, so we're just going to do PEMDAS backwards, and I'm going to go pretty fast on that because we've done that for a while now. To get X by itself, we always add or subtract first. That's PEMDAS backwards, right? And so you'd have 2X plus 0, which is 2X, is equal to 16. If you divide both sides by 2, to get X by itself, you get X equal 8. So Sarah is 8 years old. Okay? Okay, number 14. A chair is sold for $120 after it was reduced by 1/4 of its original price. What was the original price? So what we want to know and what we want to answer here is the original price is blank. Okay? And I know it's going to be some money. So I'm going to go ahead and write that down there and circle that. That gives me a place to put my answer. It also keeps my thinking on track. So let's go see what's going on. We got a chair, and it had an original price. And then they reduced it, okay? So we're going to have an original price and a reduced price. Now, I don't know if I'm going to need both of these, but I'm going to just go ahead and write them down because I know that's part of what's involved in this problem. So let's see what's here. A chair is sold for $120. So that's its reduced price, right? After it was reduced, it was sold for $120. After it was reduced by 1/4 of the original price. What was the original price? So let's think about this. You go in a store and you look at a tag on this chair, and it had an original price, and it was marked down, and the markdown price is this $120. So do you agree with me that the original price minus, wait, let me think about this. Let's see, it's okay, so it's equal to, we know that the price is going to be $120, the sale price. Let's put the sale price is equal to the original price minus 1/4 of original price. Isn't that what we would say? Basically, they reduced something by 25%. Okay. So if you think about it, let's say your original price was X. So if your original price is X and you're reducing it by 1/4 of the original price, that means you're going to reduce means subtract. That's why we're having subtraction here. And then how much are you subtracting? 1/4 of the original price. Of means multiply, so that's going to be 1/4, and then the original price was X. That's equal to your sale price of $120. Alright, so there's a couple ways you could do this. You could say this is 1x minus 1/4 of x is 3/4 x. If you remember that lazy math guy doesn't put his ones out front, you could just solve this equation. And actually a lot of people did that. Remember, you could multiply both sides by 4/3. And so if you did that, this is, I'll do it both ways. Here's this one way to do it. That's going to be $160. So you could have found it that way. Here's another way to do it. Do you remember? I'll draw a little line here. The other way we could do it is to clear the fractions, which is what we talked about earlier in Chapter 4. And so to clear the fractions, you go, okay, I can make everything a fraction, right, if I want to just stick it over 1. But I've got a 4 in my denominator, and I don't like fractions, maybe, so I want to get rid of it. So what I could do is to get rid of that 4, I can multiply everybody by 4. So this is the other way you could have done this problem. This is the way I guess they're thinking you're going to do it, because, you know, you talked about this not that long ago in the book. Now, 4 times 1x is 4x. And then 4, these 4's would cancel out, so it's minus 1x. And then 4 times 120 is 480. So 4x minus 1x, I need to simplify that side first before I can start solving for x. 4x minus 1x is 3x. So 3x is equal to 480. And if I want to get x by itself, I could divide by 3 on both sides. And when I do, 480 divided by 3 is 160. I get the same number whether I clear the fraction or I just go ahead and say, well, 1x minus a fourth x is 3/4 x. Because, you know, remember on like terms, you write your x down, you subtract or add the numbers out front. 1 minus a fourth is where we got that 3/4. So you got 2 ways to do this, and so I thought I'd just do it both ways, just in case you picked a different way than maybe I was thinking.